right. Hi, everyone. How do we feel? Sweet. Okay. So, Sean asked me to talk at Laracon because apparently the last year was a blast. I enjoyed it throughout. I hope some of you that reappear in this year also enjoyed it. And basically what Sean said is like, look, don't really care what you're talking about, but what will be the talk? Don't do that. Don't do that. So, and I wanted to basically uncover, run my usual spiel with PHP spec introduction or BDD, or modeling by example, like a basic thing, not very connected to the Laravel. And then we kind of agreed on it, and then for a couple of next weeks, I was opening a Twitter every morning, checking it up, going through the BDD hashtag, and seeing this tweet every now and then, which was like, how do I unit test my Eloquent model? Or how do I unit test this controller? How do I test drive that thing? And it kind of occurred to me that there's a set of questions that we do have answers for, but we never speak about them. And we never kind of clarify. There are a lot of things that we're using in terms of explaining things, there's a context, think about the things in terms of the context, but we never actually explain what this context is about. So I basically decided to talk about that, and if you wish, tailored talk for this conference. I'm a Rosette, or Konstantin Kudryashov, have problems pronouncing my last name also. That's a normal thing for Russian, no worries. I basically did 2-3 mistakes in my life, big ones. Bhat, PHP spec, caring about BDD too much. I work as a BDD practice manager in the company called Invika in London. And the things that I love are BDD-related stuff, learning how to communicate inside and outside of the code base, how people communicate between each other before they develop software, and how people communicate with each other through the software. And that's basically where my whole tangent on BDD comes from. I work in a company called Invika, where people allow me as a BDD practice manager to do crazy things that I'm preaching. I like to say that everything that I'm showing and everything I'm talking about is actual things that we do, right? It's not some arbitrary theoretical stuff that I think of in the corner of the company and then nobody in the company actually does. If you speak with people in Invika, we actually live by the principles we're preaching. All right, so that's a bit about me, just to give you a context. But what is this talk about, right? Because software costs, min-maxing, is what? Is it about estimation? I heard some people were talking, it's like, oh, it's about estimation. No, it's not. So what is it then, right? It's very tricky talk. Harm that Laravel facades inflict on non-suspecting developers. Bad idea that is active record and Eloquent. Other frameworks' superiority over Laravel. Killing kittens. Another subjective and non-constructive crap like that is not in this talk. Right? Sorry. Does somebody see me naked? No. Okay, what actually this talk is about? This talk is about introducing and trying to make sense of development cost. That's a topic that nobody talks about a lot, and I think it's a shame. Because if you look at the software from communicational and economical perspective, a lot of things that you kind of didn't thought about before start making sense. They start clicking, right? This talk is also about highlighting the context of tools and practices we use. I kind of made a joke about the facades and active record. I would definitely not criticize the tools themselves, but I will critically consider them and show the context in which these tools are very useful and the context in which these tools might not be good fit. So this talk is about seeing the context for the tools and trying to find and understand why for some people this particular tool works amazingly, does magic, and why for some other projects and other teams this tool is the most horrendous and horrible thing they ever did. The most important bit in this introductory slide is this talk is based on years of observations and experience. This talk is based on me going through different companies, client companies, observing projects, small projects, big projects, complex projects, obvious projects, small team, medium team, big teams, with a different context, and finding some patterns and some repercussions. What this talk is not, it's not built or based on the actual data collection and analysis. I will show some graphs that represent my observations and experience. Those graphs do not represent a collection of data throughout the world and analysis of that data, right? It's purely talk from my context, and I hope you will see some repercussions with things that you do and you see in your day-to-day lives. And if you do, then it means well, we're coming from the same place. If you don't, maybe you're coming from the different context, the one that I never seen before yet. Okay? So just to simplify, another name for this talk, and the easier one, is a context, the talk. Right. So software costs. So when you talk about costs, you usually think about things like money, right? That's a background there. In the software, though, costs mean slightly different thing usually. In the software, when we're talking about costs, we're talking about time, right? How long does it take to do this thing? Or how long does it take to do this thing? How long does it take to deliver a project? That's a cost of the project. And if you abstract everything we do with our projects, with our products, you can basically aggregate it into 3 different chunks of work. There is a time it takes you to write and test code in the first place, right? And even if you're not using automation, by the way, you're still testing, right? Don't lie to yourself. You are writing code and you're opening it in the browser, hey, you're testing, right? You are testing no matter which tools you use. You're always testing the work after you did it. That's a normal state of mind. But in addition to just introducing things or writing things in the first place, you do start after a while feel an urge to change them, right? And this phase where you're writing a new stuff phases out, and what starts phasing in is this need to change existing things here and there, right? Time to change code and tests. And again, the same with tests. If you are not doing automation, it doesn't mean you're not doing or adopting tests, right? If you introduce an authentication mechanism in front of your website and you're not doing any automation, you still will do tests, and it means you need to update your manual testing routine to go through this authentication mechanism every time you need to test new feature. And then there is this third set of things or times that we spend that not a lot of people talk about, or actually a lot of people talk about, not a lot of people do in them. Time to refactor code and tests. And we're talking a lot about oh, you need to refactor, that's a centerpiece of TDD. But the problem is when it goes into actual delivery, it's very, very hard to do these things, and it's very, very hard to reason why we need to in the first place. So for the purpose of this talk, I will give these 3 different distinct sections a names, and we will go into exploring them. So time to write and test code, I will call it from now on cost of introduction. Time to change code and tests is a cost of change, and that's a cost that you most likely hear a lot about when you're in agile conferences or you're trying to talk with somebody about the legacy project. Time to refactor code and tests, I will call it cost of ownership, right? It's a cost of owning code. So we'll go through each one of them, and I will try to give you enough context and information so that you can start making sense of those forces, and then we will go into seeing how we can make these 3 forces play with each other and how we can make sense of them so that we develop software taking them into account rather than ignoring them completely, which is the normal state of mind for engineers. So cost of introduction, essentially is the time it takes to introduce new, naturally independent, decoupled application logic. Right? So the good example of this might be, if you're building a Laravel application, create a new controller of arbitrary complexity, or create a new Laracon model, or create a new form, right? So time it takes to create completely new controller or completely new model, that time is a cost of introducing that concept into the code base. So the attributes that this model has is, it has very clear direct correlation to the business value. The more controllers you create, the more value there is to the project. The more models you create, the more value there is to the project. This cost also has direct correlation to the lines of code, to the number of lines of code. And it basically means the more lines of code require more time to write them, so the less lines of code means cheaper cost of introduction. Those two first factors basically mean that this cost is relatively easy to optimize for, usually by generalization or introduction of convenience layer. So what does it mean? It means if your cost is directly related with the amount of lines of code, and the less lines of code you have, the cheaper it is to introduce things, it's very easy to optimize. It's just like you make something introducible with less lines. In addition to attributes, this cost has very interesting dynamic associated to it. So the first and the key dynamic there is visible. It is visible from the outset. You start a project, and the first and the only cost you probably see is how long it takes you to create a new controller, how long it takes you to create a new route, and how long it takes you to create a new form, right? It's very visible, it's very clear, you can show it to the business, and after quite some time, after working on enough Laravel projects, even business can understand how much it costs to create a controller in Laravel or any other framework. This cost loses relevancy over the project lifetime, right? So the longer project goes, the less important this cost is. And a good example of this is you do not create controllers, new controllers and forms throughout the project lifetime. There is a phase where you start creating less and less controllers, less and less forms, and what you start doing is you start changing the existing ones rather than trying to create a new controller. You can't add logic anymore by just adding new stuff on top. And as I said previously, this cost is stable across multiple projects. So the time it takes to create a controller in this project in Laravel is exactly the same amount of time it takes to create exactly the same controller or exactly the same complexity level controller in another project. Business loves it, right? That's an amazing attribute. The thing is, I feel that most people focus on the first one and the third one, right? It is visible from the outset. It makes it very easy to sell. It is stable across projects, means you optimize it for one project, you suddenly optimize it for another project also. I reckon, though, the attribute or dynamic part that you need to focus most about is not this two, it's this one, right? Cost of introduction loses relevancy over the project lifetime. The longer project goes, the less you benefit or the less you care about this one. So cost of introduction is relatively easy to optimize for, right? So there are usually two ways to optimize for cost of introduction. Way number one is a convenience layer. So you introduce convenience layer in your framework or in your tool set, and that's how you optimize for it. So the good example of convenience layer is service locator, or how, as you probably know them, facades in Laravel. So if you go with dependency injection, and you will end up with the code base that is like this, right? You need to inject a cache service, and then you need to use this service later on. In comparison, a code that just uses Laravel facade is just like one line. So that's a very good example of convenience layer. Keep in mind, I'm not saying this is bad, I'm not saying this is good, I'm just giving a context to it, right? It's just two different ways to do the same job, and this one takes more lines. Another example from outside Laravel, that's a symphony. So you have a base controller. which also makes it easier to do trivial tasks in one single line of code because you extend from the base controller and you just call this method on the base one. Right? Another way to optimize for cost of introduction is generalization. So you take some problem which is very specific for that particular domain or that particular business, and you trivialize it. You generalize it to the point where like it is reusable across domains. So the good example for this is active record. Right? So active record is you have a business object in your code base, and then you need to store information. You need to store this object somewhere in the persistence layer. So usually, like the manual way of doing this is you introduce some persistence responsible object that will store this thing manually. Maybe it will connect through debug to the database. Now, people recognize that there is a set of actions that you do in most of the projects. So why do you need to create this again and again and again? Why can't we just like code this all in the base class that will provide you with like most of the 70–90% of the methods that you will need to use? And that's what active record is, right? Takes less lines of code, takes less work, convenience. Event dispatcher is another great example from outside of Laravel, and I think inside Laravel. So if you don't know, there is a pattern like from Gang of 4, which was called event subscriber. And initially, the way event subscriber works is you have an interface, and you have somebody that is dependent on this interface. So whenever something happens, you just call this method on the interface. That's how event subscriber works. Somebody looked at the event subscriber and said, look, we need to create interfaces all the time and implement them all the time. That's kind of a lot of hassle. So let's generalize it and create event dispatcher. All right? So that's another example, like generalizing on event subscriber resulted in event dispatcher. Even more interesting one is dependency injection container. That's a generalization on dependency injection. So you have a normal object-oriented code where you need to create a service and you have a couple of dependencies, so you initialize dependency, you pass them through manually, and then somebody looked at that and like, look, it's too many lines of code, right? It's too complex. You need to pass these things around, so let's generalize it. Let's create dependency injection container that will do all these things for us. So the thing that I'm trying to say here is it's very easy to optimize for the cost of introduction. And no matter what you think, optimizing for cost of introduction is not inherently a bad thing. Right? That's what Laravel does a lot, and that's actually a good thing. But it's a good thing in the context. And that context is this. It's a cutoff point of the product. So cutoff point is when you need to stop working on the project or on the product. When the product is ready, and you will probably never touch it again, you will not update it, you will not add any complex changes to it, you will probably fix bugs here and there and simplify things from this point on. No new features will be added. A good example of cutoff-based project is Basecamp. All right? That's how the first Basecamp and the second Basecamp were created. They had a very low or limited cutoff point. They created Basecamp and they said, no more features ever. We'll just simplify what we have here. Right? If you have a project with really short cutoff point, it means the cost of introduction is probably the cost you need to worry about, and that probably is the only cost you need to worry about, because when this like introduction of new controller phases out, hey, project ended. Right? So you benefited from introducing controllers really, really quick, introducing forms really, really quick. And then it kind of becomes trickier, but no problem, project ended. And you move to another project. And that's something that I feel many of you probably experienced, and that's something that I experience a lot on the short projects. Right? If the product life is short enough to not encounter loss of cost of introduction relevancy, then the cost of introduction is the only cost worth optimizing for. But keep in mind, convenience-based projects either die a hero or live long enough to see themselves become a villain. Right? And that's tweetable. Another cost of change, and that's the reason why convenience-based projects become villain if they live long enough. So cost of change is the time it takes to adapt existing application logic, your existing controllers, your existing forms, to new business realities on the ongoing basis. And it also has a set of attributes. So it also has direct correlation to business value. The more changes you do, the more value you deliver to the business. It has no direct correlation to lines of code whatsoever. Introducing 100 lines of code into code base might add value, doesn't necessary. Removing 100 lines of code might add value, not necessary. Replacing 100 lines of code with 10 lines of code might actually add huge amount of value. There is no correlation. Cost of change also very much affected by generalization. Dynamics. The worst thing about the cost of change is that it is invisible from the outset. It's complete opposite of cost of introduction. When you just start a project, you have no idea what cost of change is. The problem with cost of change is that it gains relevancy during the project lifetime, and it starts exponentially increasing over time, right? So there's the point where you stop introducing your new controllers, and then you need to actually update the existing ones, and forms, and entities, and you're like, oh shit, it's getting really, really hard. No, it's getting really, really hard. No, I can't do it anymore, right? That's a cost of change. Cost of change increases exponentially over time. I want to give you a very short example. So let's say we have this like very simplistic search mechanism. It searches packages on arbitrary package management system. Let's say you don't know what's written there, and that's kind of part of the point, so you need to learn what is there before you can do anything. So let's say we want to add tags support into this thing, right? So raise your hands if you think that it will take up to a day, less than a day. Don't lie to me. I know you will go back and that's exactly what you will say to your project manager. That's a day. Okay, 2 days. 2 days? 2 days? Okay, 3 days? All right, so 2 days, somewhere there. Okay. You know what? Let's not do this iteration. Let's wait, right? Let's do something else. There's something else more important than tags. So you're working for a couple of iterations, maybe a month or two. You know what? Let's add tags now. It's the same search, right? Same tags, same amount of functionality. Nothing changed about requirements. Raise your hands if you still think it's 2 days. Okay, raise your hands if you think it's 4 days. Okay, 5 days? All right. You know what? Let's not do it now. Let's do it later. You see the point, right? But here's the thing. Exponential increase of cost of change is not inherently a problem of every project. And that's a challenge with this cost. That's a challenge with talking about the cost of change and saying, like, you need to worry about the cost of change. The reality is not every project needs to worry about the cost of change. Why? Well, because you have a cutoff point. Right? Again, if your project stops just before you need to change things, you need to start changing things, you don't need to care about cost of change. If the product life is long enough to encounter exponential growth of cost of change, though, then the cost of change is the only cost worth optimizing for. Cost of introduction has a very short timeline, right? If it's 2 months, 3 months project, okay, cost of introduction is really cool. If it's 1 year project, those 3 months mean nothing at the beginning, at the end of this year. The only thing you care about is how long it takes to change things. And the key here is we're getting more and more complex projects nowadays, right? Making a difference in the world requires more and more complexity in the software we write. So the projects naturally grow in timeline. If you want to change the world with your product, the chances are you have a complex project on your hands, and it will take long. And the change is the primary thing that you need to worry about. And the thing about worrying about cost of change is, as I said, cost of change is affected by generalization. Optimizing for cost of introduction, in most cases, has a negative effect on the cost of change, right? You make things to be describable and implementable with less lines of code, well, that comes at a cost of flexibility, right? If something takes just one line to introduce, some complex concept takes one line to introduce, it means whenever you need to change that complex context, that's not as trivial anymore. And that's why some engineers, actually a lot of engineers, try to increase the cost of introduction in attempt to affect the cost of change, right? So it's like, okay, so if decreasing cost of introduction have a negative effect on the cost of change, why don't we over-engineer everything up front, right? Put the perfect design in front, use hexagonal architecture, use a common bus everywhere, all these things, right? Change will be easy. So here's what happens. So you have your graph, you have a support, you have an introduction of payment methods, right? Let's say you're using Cashier or newly released Spark, and that is like general cost. And then later on you will need to introduce additional payment method, and that cost increases, that's the cost of change. So what happens if you increase the cost of supporting payments in the first place? So let's say we don't want to use Cashier, we want to re-implement the payment gateway ourselves to make sure that it's like it supports change from our perspective in the future. So you move it up, right? You say, okay, that will be a bit more expensive, but now the cost of change changes drastically. Well, it doesn't really. It does change this way, right? You delay it. You delay the increase of cost of change, right? So what happens is like you're saying, okay, let's over-design that payment gateway, and then adding new payments will be easier. And true, adding first payment is easier, but then the second payment is still complex, and the third one is more complex, so you still have this exponential increase, right? And that's what upfront design is, right? AKA waterfall. That's an illusion that one can control cost of change by applying enough analysis up front. It doesn't work. And the reason why it doesn't work is because the nature and the type of change is unpredictable. And the closer you are to the beginning of the project, the more unpredictable it is for your domain. You can't predict some changes like 2-3 months ahead. You can't predict what will need to happen with this product year from now. So you can't if you can't predict these changes, you can't adapt to them. Right? And this is where cost of ownership comes. So cost of ownership is the time it takes to maintain the own application logic to support its ongoing change. So attributes of the cost of ownership. It's an intermediate between cost of introduction and cost of change. It has no direct correlation to business value, and that's a big problem of this cost, right? Maintaining things, they don't add any value to the business. Refactoring doesn't add any value to the business. Tests don't add any value to the business. They add value to you. They make you to be able to change things. But there's no value to the business in them, and that's why it's so hard to sell them. It does have direct correlation to lines of code. The more lines of code you test, you refactor, the more expensive it is, right? So the more lines of code, the more expensive it is. Kind of the same as with cost of introduction. It is always invisible, for business at least. It is always relevant throughout the project lifetime. And the interesting thing about this, it's almost exactly the same as cost of introduction, stable over time, never increases. It's a stable cost, but it adds up. So the more things you own, the more expensive it is. So for example, if you just do ongoing refactoring of 5 classes, that will be that cost. If you do ongoing refactoring of 10 classes, that will be double of that, right? And the easiest way to think about the cost of ownership, that's a fee, right? Cost of introduction or cost of change is like one-off payment, right? I want this controller. I want this change. Cost of ownership is just like an ongoing fee you pay almost like on a monthly basis. Cost of ownership is the cost you pay for the right to change particular part, module, class, method, whatever, of application continuously and sustainably. And it's essentially testing, right? Even manual testing, that's a cost of ownership, right? Your testers run through the entire system all the time. It doesn't add any value to the project except you're predicting the bugs. It's a cost you pay just because you own the project, just because you do this. Even more clear ownership, unit testing. Unit testing particular class is a direct statement of owning that class, of owning that method. And the closest one to actual clearest term of ownership is refactoring. When you change a class directly with a reason to support the future change. Introducing cost of ownership allows you to balance two other costs, right? So that's the core concept of it. That's the reason for its existence in the first place. So here's how it works. We still have our support payments and add payment method, new payment method as an increasing cost of change. So let's see what happens if we introduce ongoing payments, refactoring, and testing, right? Start paying this cost, this fee. It's basically like every time we're touching anything near the payments, we look at the payments and it's like, okay, what can we test more and what can we refactor to make it easier in the future? It's an ongoing payment. So what happens when you do this, cost of change changes drastically, even though you didn't do anything with cost of introduction, right? The cost of change, instead of being exponential, starts being something like this, right? It becomes capped. So now, because you constantly refactor, because you constantly look at your payments and you think, okay, how can I support the future changes? You make all the future changes that much easier. So the thing that Adam showed yesterday where before introducing the change, before actually adding this value of the change, you look at the code and it's like, oh, it's really hard to add this change now. What if I refactor things a bit, right? And then I introduce the change. So this quote from Kent Beck. So that's paying cost of ownership. Adam back then decided, okay, I will pay it now to make the change easy. And that's how it works, like, based on my observations. And the outcome of this process is something that people call emergent design, which is an opposite thing to the upfront design. Design emerges. Because you constantly look at this thing and you ask yourself, okay, which changes would I need to do next? Is it simple enough? Can I decouple, right? You're owning this thing. Outcome of owning is you're simplifying everything and you create design as an outcome of this. That's where emergent design comes from. It's a usual result or side effect of ongoing ownership of thing. Which is amazing, right? So let's do it everywhere. Let's own the entire freaking thing. If it's so amazing, if owning thing is so incredibly great, let's pay it throughout from the very beginning of the project, right? It's like every time, before we even introduce anything, every morning what we do, we go to the work and we read through the entire code base and see how we can optimize it, right? And like that probably will like just lower the cost of change, right? It's just like will be flat. Well, the problem with this is that you still just need to add payments. You don't need to change the entire system. You just add payments and that's it. And all this cost, all this refactoring, all this cleaning up around payments, it doesn't really pay out, right? Because all you do is change payments. That's what business wants. Business doesn't want you to change how your notifications work. Not yet anyways, right? So you keep refactoring these things. And then, of course, you heat out the thing that does matter, which is payments, but you pay so much more without any clear benefit for anyone. Owning everything fails to achieve ever-increasing benefit because you rarely need to change the entire system. That's the reality. And that's what you do when you test your system only with end-to-end tests. End-to-end test is owning your entire freaking thing. Anyone here has 45 minutes running tests? Don't lie. That's what you're doing, right? You're owning the entire thing. And all this maintenance, fixing, rerunning tests because of flickering, spending this 45 minutes to run them, that's you owning them. That's you paying this fee. Okay? But the worst thing, even worse if you can imagine, is this. Right? When you do ongoing refactoring and testing of everything except the payments logic, and then you need to add new payments. So you have you pay this incredible cost every morning, and then you also have exponential cost of change. It was just like, what's happening? I am owning thing. Well, that's what you do when you do exclusive end-to-end testing. Exclusive end-to-end testing is owning the wrong thing. When you don't have unit tests in your system, it's not owning the right thing. your cost of change will still increase. And you also pay the ownership. Ownership would not help if you own the wrong thing. You do want to own everything worth owning. That's the key there, right? So the way to use that cost of ownership is own things that are worth owning. Which brings really interesting moral dilemma. You don't know what's worth owning at the beginning of the project. All right? So just a simple recap. So you have these three costs. You have a cost of introduction. It's linear. It doesn't increase. It's relevant at the beginning of the project. It's the only cost relevant at the beginning of the project. And it's very easy to optimize for because it's stable across multiple projects. There's a cost of change, which is exponential, relevant everywhere except the beginning of the project. And it's very hard to optimize for. You can't generalize for cost of change because cost of change is so tied to your business. The third one is not cost of change. Cost of ownership is also linear. It's relevant throughout. And also, like, owning the wrong thing is bad, and also owning too much is bad, and you kind of, like, what do I do with them, right? It just doesn't make sense. It's like these three costs. Now I can make sense of them. Now I do understand what this happens. It's like if I end-to-end test everything, apparently I pay the cost of ownership for everything, and it doesn't help the cost of change. But then if I don't unit test everything, I'm owning the wrong thing. That kind of makes sense, but what do I do with it? You game it, right? Like any other cost, you basically game it. You play with it. And what I will do now is I will give you a set of very simple principles followed by a set of very simple abstract instructions that you can follow in order to game these three costs and make them work in your favor rather than against you. So the principles are, own only the logic you need to change. You don't want to own things that are not changing, right? You don't want to own HTTP stack. You don't need to change that. Taylor needs. You don't. If you just need basic payment gateway, right, just use Spark. Because you probably would not need to change it. Taylor will. But then, go even further. Write only the logic you need to own. Right? That's even trickier because okay, owning means testing and refactoring. So try to minimize the amount of things that you need to own, which is easier, just don't test, which is I'm doing anyways, right? The trick there is write only the logic you need to own. Everything else, outsource it to Taylor. He's amazing with it. Own everything you write, right? I have this repeating question, people asking me, just do you TDD everything? And my latest answer is yes. I do TDD every single line of code I write. Every single one of them. The problem is I'm not trying to write anything. I'm trying not to write anything, right? When I'm looking at the problem, the first thing I'm asking is, can I reuse something for that? Can I just use some module, some plugin? Will it help me to solve this business problem? Okay, I can't. There is no module. Okay, I need to write the freaking thing. Let me test drive it. Because I need to own it. Nobody else will. Own everything you write. Try to not write anything. Reuse everything else. Repeat after me. I'm serious. I'm dead serious. Own everything you write. Try to not write anything. Reuse everything else. Amen. So here's how you do it. You get new requirement. You had new feature. First thing you do, you always do this, you document the need. And I don't care if you use Behat or Gherkin or anything else, document what you've been asked to, exactly. And the best way to do this is usually examples. You ask, can you give me an example of how this thing should work? You write example down. I don't care how you write it, in which format you write it, you just write it down. Because you will forget, they will forget, you will leave the company, the guy after you is screwed. After you document the need, you spike. You experiment with tools available. You try to find tools that do this thing for you and get you like 90% of the way. You use Laravel tools, you use out-of-the-box tools of Laravel, right? And you try to get there. And then when you got there, you start changing it, but always when you're changing these things, test the constraints, right? Does it fit? So this new payment methodology or this new group management thing, does it really fit Spark? Or is Spark becoming a problem for your particular situation, for your particular context? And if it does, you throw this thing away, and you can't do this because you didn't spend too much time building it in the first place, you just used something, and you stabilize it. You claim the ownership of the freaking thing. If the solution grows outside of the boundaries of the tool available for you, you remove the tool and you rewrite the thing in the proper way. And the way to do this in the proper way, you isolate religiously. So unit testing your eloquent controllers, eloquent models will not help, because eloquent models are not yours. You're not owning them. 70% of eloquent model is Taylor's work. Taylor's and community's work, right? 70% of things that this thing does, even though you're like, it is your class that extends it, is not something that you own, is not something that you will change, is something that community will change, right? So what you do is in order to take an ownership, you isolate the thing that you do want to own from the things that you want others to own. So again, you document the need, you spike it, so you implement it in the easiest way possible if there is a module available for it. If not, tough luck, you jump to the step number 4. You document changes and constraints that this thing observes, and you add them to initial documents. And if this thing doesn't work anymore for your business needs, you throw it away, everything except documentation and the learnings that you had. Documented needs up front and documented changes. And you rewrite this thing according to these documents, according to these needs, according to these requirements, right? And you isolate religiously. You cannot own thing by just extending and testing it. That's not owning. Owning is, that's exactly your thing. It doesn't extend from anything. You own 100% of code there. Unit testing is owning. Refactoring is owning. Test-driven development is an ownership technique. Test, make it pass, refactor. Test, make it pass, refactor. Test, refactor, those are 2 key factors of owning the thing. What TDD does, it helps you to pay a cost of ownership on the ongoing basis in a very comfortable way. That's all there is to TDD. Test-driven development is ongoing payment of ownership, right? It helps you to refactor things to support the future changes, but it costs time. And the time it costs has no value to the business to stop selling it to the business. The value that it adds for you. So you can change things for the business in the future. And which things you need to own, well, it is kind of your call. So recap, document everything you do, spike and stabilize. You can Google for it. It is like literal technique. And use TDD for stabilization. When you're stabilizing, TDD is the best tool for this thing ever. I used all those pictures in the slides, if you didn't notice. Thank you very much. Any questions? Questions? Yes.
First of all, brilliant talk, really loved it. So you were saying to reuse components, which I definitely agree with, but suppose you're working on a really large-scale project and you end up having to use a lot of things. Say you want to implement Stripe payments, but you can't use Cashier because you're doing one-time payments and Cashier subscriptions. So you think, well, I could pull in just the normal Stripe, but I don't want to have to set the API key every time. But there's this package that is basically just a wrapper with a tiny service provider, and I can basically write that myself. And in that case, I might write the service provider myself, and it's all fine. But where do you sort of draw the line of what you could write yourself and what you pull in? Because it's really easy to sort of get carried away and you pull in 40 composer dependencies, and suddenly your project just goes out of hand and you don't really have control of it. Right.
So you don't want, well, you might want, but I definitely don't want to write anything, right? I want to pull things in. And then there is this question, when does this thing available? It's a very clear answer when like you don't have a plugin to use, right? You just need to write it. You need to write it, you need to own it. If there is a plugin, but like what to do if there is a plugin if it matches to 70% of your needs? What if it matches to like 50% of your needs? And I think there is no predetermined answer to this. It's something that your team needs to do. But no matter what you decide, there is literally two options for you to go about it. First option is you take it in, you write this thing, but you don't take ownership, and you incur potential cost of change later on. And another option is you're taking it in, you isolate religiously, and you take ownership of the part that this package does not provide. I would prefer personally the second option, and the teams I'm working with would probably prefer the second option, but I don't think it's like right or wrong answer.
Okay, and a sort of follow-up question, what about, because there are a lot of packages, if we talk about Stripe in this case, for instance, Cartilist has a great package on Stripe, but I don't really need all the functions of that, but I don't really have one that, say there's one package that matches to 70% and another that has 240% of the features I need. What's sort of the way to go about that? Do I want to build upon the 80% one and just extend that to my own, or?
So this is kind of different question altogether, not really tied, but you generally consider the costs of having that thing in. I would usually answer that, why would you care how much features it has if it doesn't force you to use that feature, those features, right? If it doesn't force you, if those features are still hanging there and you're just not using them, it's like, why do you care? You're not taking ownership of that thing, right? You're just reusing them. If it does add some instability problems, if it does slow you down, then you're going into all different conversations like, does it worth actually owning this thing on your own? And this is a consideration that I would have with the team and discussion that I would have with the team. A good example actually from the life, our team worked on the Drupal project, and the guys used some import script from Magento because they were trying to integrate two systems. And they used out-of-the-box Drupal module for that. Not out-of-the-box, but it's like some of the community modules. And they end-to-end tested the whole thing just to like through the critical pass, just to make sure that it works. Not went crazy, but they basically didn't take much ownership of the thing. And then they started flickering. So it's like the basically import worked every second time by the clock, but it didn't work every first time. So what they did, they had a discussion as a team with the product owner, and they said, look, it's very risky. It doesn't really work in the way we do. So what do we do? And they decided to rewrite the thing. So they dropped the module and they wrote their own logic for importing the couple from Drupal, and then they introduced the module that integrates it with Drupal. So it took them like 3 more days instead of just like using out-of-the-box thing, but then they have a very stable import, and as a side benefit, it was working like 10 times faster than the Drupal module out of the box. So that's just an example of how you can go about it. There is no strict answer, it's just like, here's the thing that you always will need to do in this case, right? Which is non-answer, I granted, but That's the best one I can give you.
Okay, thank you very much. It was a very good answer.
Thank you. Any more questions?
Hey, Abizet. I just wanted a little bit of clarification on what you mean by isolate religiously. I'm assuming that you mean implementing interfaces and adapters to kind of isolate your application, your business logic from the dependencies?
Yeah.
Okay.
Yeah. There are many ways you can isolate things. The classical OOP way is a breach pattern. So you introduce an interface which you use to define what this thing needs to do, and then you implement this interface as a boundary. Ports and adapters is another kind of tangent on this that you can read into. Ports and adapters, breach pattern, read into these two things that will give you enough information to know how to isolate religiously. But that's the thing you need to do if you want to own anything, and you kind of want to own everything that you write. Any more questions?
Continuing on from that first question, how do you manage or sort of factor in the risk of all these multi-dependencies not necessarily having long-term support, or even them not taking ownership and you suddenly, being exposed to that?
So that's a very great question. Thank you for this one. The thing that I didn't touch upon, and that's like something that I alluded to in the previous questions, is do we need to use the plugin on the module for that, or is that module good enough? That's the whole separate discussion for you and your team. And for me personally, anything that doesn't have tests in it, either a spec folder or a test folder, is not a good module for me. It by default means that this module does not exist in my eyes, right? Because simply because I cannot take onto risk of that module being broken and nobody knows, including its author, that it's broken. It's easier for me to take an ownership on that responsibility or find a better module, right? So stability is the important thing you need to take into consideration, same as speed and the general performance hit of the module. So those three things you keep in mind when you are taking up one module. And basically the threshold you set yourself and the team for that thing, right? And it's a basic threshold. It's worth, as a team, when you're starting a project, to agree on that threshold. So it's what is the set of requirements for every module we're integrating into this project, right? And you can say with the team, if thing doesn't meet this threshold, do we pretend that it doesn't exist, or what do we do, right? And you make an agreement. So in our case, agreement is if it doesn't hit our needs, we just pretend it's not there, and then we'll look for another module, and if there is no another module, we just write it. And we try to open source. We will probably open source it so that others don't have the dilemma that we have. Right? Did it answer? Yeah. More questions? Oh, we don't have time for other questions.
We can do one.
One more question?
Anyone want to be the special last question? No pressure. No.
All right. I'm here till the end of the day. So find me, talk with me about this thing. I find it fascinating. So share it with me. Please leave a feedback on the joined in. Thank you very much again for coming and spending an hour with me.